Physics Calculator by Felipe Fernandez and Juliana Lara. We now will explain the 5 benchmarks and the additional problem, and later we will explain how does this calculator work. This is benchmark number 1. First, we start plugging in what we know. We know that the acceleration in the y-axis is the gravitational pull on Earth, and it is negative 9.8. And we also plug in negative 9.8 for gravity because the gravitational pull on Earth is negative 9.8. Then we are given that the angle is 36.5 degrees, and we also know that the initial velocity is 95 meters per second. So we plug that in, and then we know that the displacement in x is 880 meters.
In benchmark number 2, we first have to put negative 9.8 in the acceleration of y because it's the gravitational pull on Earth. Then we're given that the velocity initial is 125 meters per second and the angle is 15 degrees. When we plug in those variables, we get that time is 6.6 seconds and displacement in the x-axis is 797 meters.
In benchmark number 3, it's the same things as benchmark number 1, but the gravity changes because it is the gravity on the moon, and in this case it equals 1.62. So we plug that in, and then we plug what we know about benchmark number 1, that was the velocity initial, and the angle, that is 36.5, and then we are able to know the displacement in x, that equals 5,327 meters.
In benchmark number 4, we first have to input negative 9.8 in the acceleration of y. Then we have to put a velocity initial, which we are told that is 500 meters per second. Then we have to put 50 meters, that is the displacement in the y-axis, and then 58 degrees, which we are also told. And then you get that time is 0.1 seconds or 86 seconds.
In benchmark number 5, we first have to input the acceleration in the y that equals the gravitational pull on Earth, that is negative 9.8, as well as gravity. Then the velocity initial is 25 meters per second. The angle is 67 degrees, and the delta y will be negative 10. And then we find out that the delta x is 49.787, and the time is 5.09, because time can never be negative.
First, we have to input, as always, a gravity, which is negative 9.8 meters per second squared. Then we put that velocity initial is 7 meters per second. Then the angle, which is 15 degrees, and delta y, which is negative 12. Then we get that time is 1.7 and delta x is 11.90.
These were the 5 benchmarks and the attached problem, and now we will explain how does this calculator work. To explain how to use this calculator, we invented a problem. So in gravity and the acceleration in the y will always equal the same, that is the gravitational pull, and in this case in Earth it's negative 9.8. The velocity initial is given, and the delta y and the angle is also given. So when we are told these things, we will explain how do we get the delta x and the time.
When using one of the big 4 formulas, time is an independent variable in a quadratic equation. So we use the quadratic formula in order to get the independent variable, which as an end is going to be time. That's why we get two answers. When we have two answers for time, we have to choose the positive one because time, as we all know, can never be negative.
To find the delta x, we use one of the big four formulas, and in this case we use displacement equals 1/2 times vf minus vi times time.
Velocity initial will be the hypotenuse in a right triangle, and Vox will be the adjacent angle. That's why we use cos of an angle times hypotenuse, which is Vi. Vox will always be the same as Vfx. As we said before, Vox, Voy, and Vi are in the form of a right triangle, and Vi is the hypotenuse. So to find Voy, which is the opposite angle, we have to use sine times angle times times Vi. Voy and Vox will always be the same.
And for last, we always know that with these problems, and always time will be the same in the x and y axis.